Hello and welcome back to another Python tutorial. So we are continuing our series on K-means. This is video 3 of that series. In the first video, we gave an overview of kind of what K-means is, what problem it is designed to solve. We then also saw a visual example. Second video, we did more of the data collection and some of the transformation. So that was taking our data, getting the API data that we needed, and then putting it in the right format that made sense for us. In this video, we're going to be selecting our attributes, and then we're going to also just do some basic visualization about our data set. And then we're going to discuss some concepts that are more related to, just machine learning in general and things like that. So, all right, so we have 46 columns of information. Now, technically speaking, you could cluster on all 46 columns, but sometimes that doesn't make sense. And this is where we're going to start getting into the challenges of working with larger data sets. Now, people might say 5,000 rows and 46 columns, that's tons of data. It's actually not that big. There are some data sets that some companies have to work with that are in the billions and billions of rows, and just the amount of columns they have, I mean, it can really start being overwhelming. And so in order to kind of understand certain concepts, I'm going to purposely be restricting the number of attributes that we have to work with to 3. The reason why is I can visualize 3 dimensions of data for you very easily. You start asking me to visualize 5 or 10 or even 20 dimensions, it's you just can't do it. It's very challenging. I mean, people have kind of claimed in a sense they can do it, but it's not going to be in the very traditional sense that you're used to. And some of these concepts that I want to kind of drive home, it's just going to be easier to restrict it to 3 dimensions. And so with that being said, we will be selecting 3 attributes. The first one is return on assets, return on equity, and then return on investments. And you might be going, well, Alex, how did you know that these were going to be the ones that work? Well, part of the luxury that I had is I experimented with a bunch of different attributes. And so some attribute combinations don't make sense. There's no structure behind it. And so it doesn't make sense to use them as indicators for clustering. Again, this is the challenge of it. I mean, a lot of people think, oh, the first time I did it, maybe that was the answer. Once in a blue moon that happens, but very rarely it's iterative. You have to explore and say, does 3 attributes make sense? Does 5? And which attributes? And really, how do I structure it so that way I can find some hidden structure behind my data? It's not clear cut. Part of what influenced my decision was I actually started researching some papers that I found online. And so I will be providing this inside the Jupyter Notebook, but I encourage you, go read some of these papers and see what other people have done. Basically, in every paper I saw, this one and this one was pretty much done. And that kind of makes sense, because if you look at the definition of return on assets, it's really telling you, how well is that company managing, or basically how efficient is that company managing and using its assets to generate earnings. If they're doing a great job, you should see a good return on assets. Again, with another indicator, we have return on equity. This is another financial performance indicator. But this is again saying, it's more in a sense of how are they using the assets to create profits in a sense. So it's not the same as return on assets, it's a different measure, but it's again a performance indicator to say, are these companies doing a good job? Return on investments, how well as an investment has this been doing as a stock? These kind of attributes can help us create a cluster that maybe makes sense. Maybe we believe there's bad performing companies, we think there's average performing companies, and then we think there's just those exceptional gems, the ones who crush it on every single indicator. These 3 attributes might be the ones that we need in order to create that structure. Now, maybe you say, Alex, I disagree with you. I think return on assets is the stupidest thing you could have used. By all means, disagree. Choose another one. I'm not there to say that there's nothing better in here. I mean, there might be a better combination and it might provide better structure. You're going to have to experiment a little bit though. The other thing that we kind of need to talk about a little bit is, and again, this really doesn't necessarily apply in this particular data set because we're restricting it, but Sometimes if we select too many attributes, it's not really telling us more of the story. And we'll kind of explain this in the next video a little bit more, or at least I think it's the next video. No, I think this one we're just focusing more on the outliers and plotting, if I remember correctly. But basically, what can happen is it was kind of like linear regression, which is, does it make sense to actually have that additional column information? Is it actually telling you anything new? And if it's not really telling you anything new, it probably doesn't make sense to have it in the data set. And the reason why is it's going to impact the performance of your clustering algorithm. K-means is not the fastest algorithm out there. In fact, there are faster ones, but it's easy to understand. That's why a lot of people go to it, is they can understand the mechanics behind it. And so if you keep adding attributes, yes, you might be adding what you think is more information, but it's not actually contributing that much. And more importantly, you can have a performance problem. And then also, and this is, again, I think this is just to help visualize that concept. As you add more attributes, the tendency for your data points to move further and further away is going to increase. And so it's going to be hard to find data points that are actually similar. For example, just take a simple example like this where we have height and weight. Imagine I just plotted inches. Well, okay, they're relatively close to each other, but the minute I add a new attribute, now they're moving further and further apart. And so because of that, if we keep adding attributes, it's going to be harder to find structure behind it because the data points are going to be so far apart. So it doesn't necessarily always call for to add more attributes. It can actually get us into trouble sometimes because we won't be able to actually group them as effectively as we might think. And we'll see kind of steps we can take later on how we can fix this problem. So with that being said, I just wanted to give you some background about why I chose this. A lot of it was influenced from other people's work, but this is how you approach it. You've got to find attributes that make sense, things that you would think define different groups. Okay, so the first thing we're going to do is define our indicator list. So we'll call it metrics list, and we'll call the first one return on equity, return on assets, and then finally, well, not finally, but return on investments. I will also need to make sure that I have each symbol because that will make my life easier. I can use that as an index component. And so what I'm going to do is I'm going to basically take my data frame and I'm just going to select the columns that I need. Select only the columns we need. And so we're going to call this one indicators df, and we're going to take our stock df and we're going to pass through our metrics list. Ooh, did something wrong. Okay, and then from here, we're going to display the new data frame. And so we'll say display indicators df. Okay, metrics, return on investments, return on investments. It's not an S at the end, it's just a T. Okay, so from here, we've got our data set, but we still got a problem, unfortunately. K-means cannot handle missing values. You cannot provide missing values to K-means. You have to fill in your blanks or you gotta drop them. In our video, we're just gonna drop them. Now, you could technically do other things, like you could maybe do an average or something like that. There's really ways you could do it. It's kind of up to you, and it really also depends on the type of problem that you're dealing with. But the important part that you have to understand, you cannot provide missing values to K-means. So what we got to do is we got to filter this data frame because it's not going to work the way it is. So remove missing values. And these aren't technically missing in the sense of NA. These are just 0. They have a 0 attached to it. And so what we're going to do is we're going to take our indicators df and we're going to basically filter out the 0. So we're going to call our indicators df, and then I'm going to do indicators That's a lot of indicators. It's too many. Metric list. So this is basically just selecting those columns that we already defined up above. And we're going to say this. They cannot equal 0. They cannot equal 0. They have to, they can't equal 0. So what we're going to do here, and then finally, if there's like any missing values, we can also remove those as well, because for some reason, some were left behind and I'm not really sure why. And so what I do is I just remove drop NA as, again, a final one, and it says how, just do any. If you see any missing values, just drop that row. That's all. And then display the cleaned data set. That's all. And so we're going to say display indicators df, and then we're going to call head. Oh. I want that to be head as well. Metrics. Okay. Okay, so now we have a data frame that does not contain missing values. So we just had to do a little transformation to kind of fix everything. And then finally, what we need to do is we're just going to set our index, and we're going to convert our data frame to make sure that we have removed, or sorry, convert it so that way we can make sure that it's all floats. So first thing is set the index, set the index, and we'll say indicators df, and we'll say indicators df dot set index, and then we'll say, hey, set that symbol column to be your index. And then from here, we need to convert our data frame. So convert the data frame to float. And so we'll say indicators df equals indicators df dot as type, so the as type method, and then we just got to define what we want it. We want it as a float. And then finally indicators df dot head. Okay, so now that's our new index column, the symbol column, and then everything's been converted to floats. Wonderful. Okay, one final thing, and then I am going to call it quits on this video. I'll save plotting for the next one just because I think it's a little bit too long at this point. We're going to remove outliers, and then we're going to do a quick statistical summary for us. So something you should always do, I mean, you should be doing it anyway, you should be making sure your data is actually doesn't have any outliers. There were some data points in here who had ROEs of 20,000%. I can't include those in the data set because it's going to screw everything up. The reason why, and it's again kind of more important to visualize it, imagine you had a data point like this one all the way over here. That could potentially be its own little cluster. And so by removing that, you're basically making sure that these structures, these clusters stay very well defined. You don't want your outliers influencing the structure of your clusters. K-means is very sensitive to outliers. So what we're going to do is we're going to obviously remove the kind of obvious ones in the sense of, hey, you know, this is 20,000%. This is just not going to work. That's not realistic. And then we're also going to do some transformations before we actually start modeling. We're going to see how we can normalize and scale our data so that way we help remove that issue. Okay, so first thing is we got to define our filters. How do we do this? Like, honestly, how do we figure out which one is considered an outlier? Basically, what I did is I just took an industry average, and I'm saying if it's a lot bigger than the industry average, it's probably, you know, it's a little bit too high. And so the nice thing about this gentleman on here, I think it's the NYU Stern, they have all these different averages for the different industries. And so basically I'm just using that as my benchmark as to which ones to remove. And so really what we're going to do is we're going to define our filters. And so we're going to say ROE filter. So in this case, we're going to say what's the filter for the ROE. And so we're going to say indicators DF. We're going to use iLock, so index. And we're going to say take the first column. The reason I'm doing this one is I wanted to make it a little bit more generic. This really, because you might be saying, well, why am I doing iLock up here, but I'm specifying it up here? The reason why is I was doing very iterative processes where I was changing which attribute I was using. So by doing it like this, where I'm saying more generic, just take that first column, then we kind of remove that problem. And so what we're going to say is, hey, if the ROE is greater than 40, remove it. And then we're going to basically repeat this process for each indicator, but I'm going to define it differently for each one. And so we're going to say ROI, and then this one, I'm going to say 30 and 30. So I'll again put these links. Really, I just took the industry norm, and if it was kind of drastically above that, then I was going to remove it. Okay, so the first thing that we need to do is, I'm always curious, like, how many did it actually remove? Because that was kind of dictating, as like, this kind of doesn't make sense or whatever. So I get the count for each column. And so what I do is I say ROE count equals panda series. I'm going to do ROE filter dot value count. And so this will tell us how many are above or below, and so on and so on. And so I'm going to do this and do this. This, again, is just giving me an idea of potentially how many are going to be removed. And then by telling me, okay, how many meet that criteria and then how many don't meet that criteria. So this is more for me to understand, hey, before I do this, is there going to be like a drastic drop in my data set? It might not make sense to have that as the filter. That's really what it's doing for me, at least, because I like to know before I start dropping, 50, 100 rows. Okay, so we'll do ROE, ROA, and then ROI. Alrighty. Perfect. So it looks like, for the most part, ROE, there's 1,900 who do not basically, or who aren't going to be dropped. 193 would be dropped from this one, and then 315 from this one, and then 315 from this one. It seems a little, oh, I know why. I'm like, that doesn't make sense. That's not higher. Okay, sorry about that. Sorry. And so 193 from this one, 44 from this one, and then 81 from this one. And so let's apply our filter. So filter the entire data frame. And so we're going to say indicators df is going to equal indicators df. And then we're going to apply our filters. We're going to say ROE filter and ROA filter and ROI filter. So basically, if any of these conditions are met, then drop it. And then display the head. Okay, indicators. Indicators df dot head. Okay, perfect. Let's just do one final thing. 1866. So that looks like how many we got left with at the end of the day. What happened? No, that should be fine. 012. I think this is the one that I gave before, if I remember correctly. That's strange. ROE, ROA, ROI. I mean, it's fine, but it's strange that it's still doing that. But basically, that is how you filter it. Oh, it still gave me that warning on there. Okay, I'm not crazy. My bad. So from here, we filtered it. So we've done our best to remove outliers. So we just did the obvious ones. Now from here, let's kind of just do a statistical summary. So that way we kind of, do a sanity check to make sure everything kind of looks at least relatively normal. So create a statistical summary. And so what we'll do is we'll say description df will equal our indicators df, and then we'll do the describe method. Okay, and then I'm picky. I like having a standard deviation metric, so add the standard deviation metric. And so what we'll do is describe df dot location, and we're going to say +3 underscore std equals describe df dot location, and then we're going to take the mean, and then from here we're going to do plus And then we're going to do describe df dot location. And then we're going to do these standard deviations. So 3 standard deviations away. And then we're going to times that by 3. And then I'm going to copy this. Not all of that. And then I'm going to put this below. I'm going to do negative. And then I'm going to do minus. And then finally, display it. And so we'll say describe df. It's always something mean. It should be fine. Indicators df. Describe df. Describe df. Did I write something wrong? Well, let me do this. Let me make sure I got something first. Yeah, that's strange. We did a float conversion. It should be converted. Oh, for God's sakes. No. Yep. Oh, Lord. Okay, sorry. I had a typo up there. I'm like, wait a minute. I know I had it. Oh, and that took away the warning too. Wonderful. Okay, so this is what we should be looking for. So you can tell it's got a statistical summary for us. We got the max, we got the standard deviation. So again, for the most part, this stands right where we want it to be. That's a little bit high. Yeah, that's a little bit high too. But for the most part, it'll do, at least for demonstration purposes. We could maybe drop a little bit, but at the same time, you're going to have companies that are outliers. That's just the reality of it. There's going to be some who are a little bit above average, but as long as they're not drastically over average, that's for the most part. And you could always play around with. I mean, you could say, hey, if I really restrict it, is it going to kind of throw things off or things like that? So there's things you can do if you wanted to. So with that being said, though, I am going to kind of stop the video. So if you have any questions, I forgot to mention the first 2 videos, obviously, put them down below. And then in our next video, we're going to do the plotting. And then we're going to also talk about principal component analysis. So thanks again for watching, everybody. We'll see you in the next video.